Okay, thanks everyone for joining us. Looks like we've got a good crowd here for our data mesh meetup here with Pete Brown from AutoZone. And Pete is going to take us through what he's been doing with data mesh at AutoZone. And it's from a pretty interesting angle as well, because it's coming from more of a networking side. And Pete has published slides and has done another meetup, and we'll be giving a presentation at a conference on this as well. So really excited about everything that he's helped with on the community side, and really excited to kind of see where he's taking this. But as per usual, I'll be on mute until we get to the Q&A side. But with that, Pete, thank you again for taking the time, and go ahead and take it away.
Thanks, Scott. Appreciate the intro. So this talk is it's a little bit different from, as Scott mentioned, it's going to be different from most of the other content you've seen on data mesh. That's due to the fact that I come from a network engineering background as opposed to data management. And so we approach this from a completely different angle, and we'll be focusing on, we won't be focusing any at all on people and processes as much as, as people in organization as much as we will our implementation and the process we have put in place. So a little bit about myself. I've been hopping around infrastructure for the past 2 decades or so. And one of the biggest pains in my career has been data sharing. It's not learning the latest, greatest technology. It's not whatever. It's just getting people to share basic info. And so the last couple of years of my life have been spent trying to find a better way to do this. And when I came across Jmesh's original article, it just, like everybody else is saying, it just a light went off, and I knew that was the way to go. So the agenda for today, we're going to take a look at the challenges that we run into from an infrastructure perspective as far as data gathering goes, some of the traditional approaches to integration, how mesh integration can help us out with this, specifically implementing aspects of data mesh. Going to do a quick demo and then the Q&A. So one of the great ironies of working in IT is that we're entrusted with the business's data, but we often have a very hard time managing our own. And so the challenge we run into here is we have data from a bunch of different infrastructure source types, and they're constantly changing. So how do we mitigate the impact of when things change, and when instances come in and out of the environment? How do we adapt to those changes as fast as possible? So when we're talking about infrastructure sources, we actually have there's a bunch of different processes involved in the management of infrastructure data. We go out and we buy tools, monitoring tools, analysis tools. We buy all these things to help manage our own data. We write a bunch of internal ad hoc processes to interact with the data, doing analysis on it. We develop dashboards, and we maintenance processes, all these things. So by the end of the day, you end up with something like this, where it's this big spider web of point-to-point integrations. And it's a fragile approach, because when something changes, everything that touches it has to change as well. So to give you an idea of the types of sources we're referring to, we might have in the AD world, in Microsoft Active Directory, you're going to have the AD management. Usually people are using Azure these days for that, but you have the directories of employees. On the network side, you have inventories of routers, switches, your IPAM, your DNS management. InfoSec has their own data sets as well as telephony. And these are just some common samples that most organizations are going to run into. So let's say you need to take some data and bump it from one system against another. Common example would be a list of Active Directory users. Somebody comes along and says, "Hi, need a list of AD users." Here you go. What do? You get a spreadsheet. Everybody gets a spreadsheet. That's no way to go. So you want to automate it. What happens? Well, that might be challenging because most of the time the owners of the systems are just going to give you more spreadsheets, and you have to take your script and process that, and that's no fun. So if we want to integrate directly with it, though, that brings its own set of challenges. If we look at some of the sample sources for common infrastructure components, I'm a big fan of Cisco and their product line, and so I tend to use there's my demos. Meraki, we integrating with that APIs is not too bad. We use REST. They offer an open API spec, but a lot of the other, especially traditional data sources in the infrastructure, it's a wide variety of protocols. It's a wide variety of data formats, and some of them may or may not even offer the open API documents to take advantage of, and it can be a huge mess. So when we're trying, so let's say we want to go ahead and proceed with this. Every time somebody wants to integrate with a source, they have a series of steps they have to follow. First, they have to study the integration interfaces, SQL, LDAP, so on and so forth. You have to get libraries for that interface in your language. So maybe you get some npms for Node.js. Maybe you get some Python pip packages. Could be many things. You have to discover the instances. You might have one AD in your environment. You might have one instance of an AD. You might have a big nested tree that you have to integrate with a bunch of different instances. Finally, acquire roles and credentials. So you have to go to each app owner, the owner of each instance, get your credentials. That's no fun. And then finally, my personal favorite is the routing and firewall issues. So after you've gone through all the other headaches, now you get to deal with InfoSec. Of course, we love InfoSec, but still, one more thing on the list you have to do. Let's say you've accomplished this. You've written your script, it's gone out to all the things, and you've done it for one set. Great. After the past couple of weeks, you have now successfully integrated with maybe three sets of sources. Now you get to do it for everything else that you want to integrate with. And so this is, people spend years on these types of projects. I know I have. It's no fun. So the question then becomes, how do we make it easier? How do we make it easier to discover and integrate with our sources without having to go through all those steps for each one? And the answer is to make everything declare itself. So enter data mesh. The key items that I've taken from this are going to be the discoverability, the addressability, and the self-describing features. It's very important because if a person walks into an environment with very little knowledge of everything going on around them, they're going to be operating blind. But if you can put them in an environment, give them tools that lets them easily see, hey, what's out there? How do I get to it? Make it describe itself so I know what kind of data it offers. All of a sudden that person becomes much more effective in their given role. So what we ended up doing was, and we'll go into the rationale here in a bit, but a couple of years back, we started working on a protocol that would allow sources to do this. And we called it DRP, Declarative Resource Protocol. The key takeaway here is it allows consumers to focus on data analysis functions, and by reducing the time you spend on discovery, connectivity, integration. And it does this by offering the mechanism through which sources are discovered. And because in DRP, everything is declared, nothing is discovered. It's you should never have to go out and find the system, and it should just be there. It should be a buffet. It should be like walking into a buffet. You see what's there, and you can take whatever you need. I know that sounds oversimplified, but really it's not. So also in DRP, consumers should have a single logical endpoint to access all of your sources. Now, again, this is not, notice I did not call this a data mesh protocol. It's a service mesh protocol that we baked some data mesh features into. So there's I do want to make that distinction. I would not call this a data mesh protocol. There's no such thing as far as I know. And finally, consumers can use with DRP, consumers can use a standardized mechanism for all of the, not just RPC, but also your pub sub for streaming. So let's take a look at what DRP looks like. In DRP, we have different roles. All of these things would normally be clustered, but for the sake of clarity, we're going to have one at a time here. The registry acts as a control plane. This is really what bootstraps the mesh. They find each other through DNS server records, just like Active Directory. And the other feature of the other really important item about the registries is that you can route traffic between non-listening nodes. We'll get to that here in a moment. So providers, of course, the mesh would be useless without data. And so the providers are there to inject services and declarations into the mesh. For native services that are not mesh capable, which is 99% of what's out there right now, we would have a provider act as a shim and expose the native services. So it may be Cisco Call Manager, it may be Meraki's APIs, could be anything. And so the provider is going to take those, it's going to make those declarations and broker calls on the native services behalf. Loggers, obviously we want to log everything that's going on in the mesh. And so we have a logger type that the other nodes can send their logs to. Broker, this is another key item. Brokers simply listen for requests from consumers and route them to the appropriate service on the back end. Brokers are responsible for locating and routing traffic. And then finally, our consumers. A consumer could be a persistent process that uses WebSockets for connectivity and listens to streaming data, or the consumer could be any RESTful client. It could be a script, it could be a daemon, it could be anything. So now, obviously, we would not want to have just single instances of all of our items in the mesh, and so this is what our production looks like. And obviously, we're going to have multiple zones, multiple data centers. We're going to have multiple copies of each service in each zone, and the DIRT protocol will, when it gets a request for a service, it's going to route it to the closest instance within a zone and the most preferred instance of a service within a zone. So if we go back to the example we had before of direct access, we went through the trouble of going through all the steps for each source and integrating with it directly. That turns into something along these lines, where now any RESTful client can go to a broker using a given resource path and tell the broker, I need to talk to this named service. I need to access this streaming data. And it will turn around and the broker will make those requests on the consumer's behalf. So we've changed from having to go through all those steps to simply acquiring the roles to get access. So as long as your user or your API key has the necessary roles, then you no longer have to go through that entire process to get to new services on the back end. So we replace the you get a spreadsheet. We replaced that with declarations. Now, anybody who's ever played with UML will recognize this style of format. It's UML-ish, and we may be moving to something else, to another format. But for now, this does the trick there. And if you look at the declaration, you'll notice that we declare what classes that a provider offers. And we also use stereotypes to we tag the fields with metadata so that we can easily find out which items in different classes are related by using those stereotyped values. So we go from what we had before to the big spider web of integrations, to everything on the mesh is declaring its classes, it's declaring its streams, and more importantly, the mesh also offers the mechanism by which you access the data. So it's not just giving you the roadmap, it's giving you the road. So the next question is that, the title of this talk is, sharing is caring, data mesh on Cisco IOx. So why do we bother reinventing the wheel and making our own mesh protocol? I mean, that's a lot of work, but why? The reason has to do with complexity. Because if you look at the products that are generally used to implement a service mesh or implement queuing or cataloging your APIs, you usually end up with a variety of services with a pretty big stack. If maybe you're running Kafka, you're running Istio for your service mesh, you're running ActiveMQ. It could be a number of middleware components, and they're all going to have sizable stacks to them. So if we take a look at, let's say we start off with the services that you're offering, and we say, let's put this on a service mesh. Let's use Istio. Okay, so then you add in the Istio stack, including all of its VMs and miscellaneous dependencies. Then we add in Kafka and a few other middleware components. And before you know it, you end up with a huge footprint simply for your middleware components. But what if you didn't, have to do that? So the problem here is too many infrastructure dependencies, too many middleware services, too many dependent servers, when it's not 100% necessary in all situations. So enter Cisco IOx. Cisco IOx is a containerization. It's an application hosting technology on Cisco routing and switching devices. And what you can do is you can run applications on it, absolutely. But the idea that we had here was, well, why don't we take the mesh and run the backbone of the mesh on the network, eliminating the majority of your infrastructure components, or eliminating the majority of your middleware components where they're not absolutely necessary. So what we end up with is, instead of having that giant stack, now we simply have the network devices to which your application servers connect to for mesh connectivity, and then your actual mesh containers or mesh process, the backbone processes would run on the network devices, striking out again a great deal of infrastructure dependencies. So right now I'm going to show you a public demo of what all this looks like. Unfortunately, I can't show you the internal one, which I love it. It's a pretty decent sized environment. And here we go. So this is a page that anybody should be able to get to. It's called jmesh.io. It's just a public demo for the mesh software, which is also an open source project. And if we look at the DRP topology, we see we have the registry. We have the brokers over here on the right. We see our consumer connection. I've signed in as Bill. And more importantly, the providers on the left-hand side. What I did here was I created a very simple commandlet for showing. So we see the topology. Well, let's say we want to know what classes are offered on the mesh. So we would say dm-l to list the available classes. And let's say we wanted to describe those classes now. We could get more information on it. Let's say we want to get information on the person class. It'll go through and give us, that UML-based data that we had. And then more importantly, we can do a get on that same class. Now, one thing you may have noticed was there was no specifying addresses directly to target surfaces in the back end. It dynamically went out. It will dynamically go out, find the best instance or all instances of a given class, and pull the data back. From an infrastructure perspective, this is very important because if somebody said, I need to know, I need a list of all DNS entries that point to this target, or I need a list of all people that are in this department, then it makes it easier for us to do queries on the data without actually having to know, one, what services offer it, and two, what's the pathing to it. So this is something we found pretty useful over time. The other thing we can look at is one of the primary reasons we did this was to allow us to process streaming as well without implementing ActiveMQ or anything along those lines. So we can take a look at all of the streams by, excuse me. All right. And by running a watch. You can do watch with a listing. It'll show us all streams available in the mesh. There is a test stream. So we're going to watch our test stream process. And that process is simply kicking out dummy data here and there randomly. It's, of course, this in itself is not very useful, the test stream, but what we like to use it for is in the case similar to the data classes where you might have a person class in 10 different services. You're also going to have things like REST logs and 10 different services. So one of the things we use this for is when we're trying to debug certain web processes, we can say watch global REST logs, and it'll kick up another window, and it will, the next time somebody were to do a get or a post or what have you, we can see all the web logs as they're streaming across in real time. One situation that we found this critical was in the observation of credit card logging, because AutoZone is a large corporation with over 6,000 stores, and if there are any problems with the credit card processing, then you need to be able to find out quickly. And this was one of the tools that we ended up using to start monitoring our credit card logging streams in real time. And people built some really interesting tools for the visualization out of this, because they didn't have to go through all the integration steps. They didn't have to go through all the things. They could relatively easily tap into the mesh and say, declaratively, I need this data, without having to understand all the various all the various things you would have to normally understand, such as how to integrate within all the instances, yada yada. It's not necessary, and that's one of the again, that's probably the most critical functionality that came out of this. So I have been talking for a good minute now. Let's go ahead and take some questions.
Awesome. Thanks so much, Pete. One thing that I wanted to talk about is, a lot of this is specific to it, or the genesis was from the networking stack. right?
Correct.
But what you just talked about was that you were able to in real time kind of monitor what you're doing from credit card processing and things like that that are completely not at all necessarily on the networking stack. So how do you think about, I mean, obviously most people doing data mesh are trying to create kind of a zone for analytical information, right?
Yes.
And most of the people that are, watching this either live or recorded are probably not thinking about, oh, I want to be looking at the networking data. So like, what do you think from what you've done here is applicable? Because like what you just talked about at the end of like, it sounds like you've built something that does some like kind of crazy level of discovery for people in and of themselves, right? So how would you recommend that people take what you've done here and kind of apply that to what they're thinking about?
Sure thing. So if you think about a data catalog, many people may have a hard time putting together data catalogs because they lack visibility. They can't enumerate all the sources. They can't get everybody to pop their data in there. But if the sources declared themselves, and if the sources were to offer the correct the correct declarations on boot time, then a process could sit there as a watchdog and say, do we see any topology changes in the mesh? Do we see a new service that we don't have in our data catalog? And if so, somebody needs to be alerted to this so that we can make sure that we have properly cataloged everything we're seeing in real time. So you could have a watchdog attached to your data catalog process that monitored the live topology of your application mesh.
Okay. And so, I mean, when people think about like data mesh specifically, in general, we're not going to have ephemeral data products, but you might have ephemeral data within that, especially if you're thinking about like SLAs around data of hey, we're going to keep, this data product, gets refreshed every, 30 minutes, and we only keep in here, 6 days worth or whatever, that it's like, oh, that this might be popping up and going away. But I do think especially I've kind of talked about this as well of getting data into the data catalog. I think every data product should be broadcasting out, as well as having kind of that manual intervention and having your documentation that lives with the data product itself in the code, as well as into the data catalog, just so you've got all those redundancies of people that are trying to figure that out. There were a couple of things in the chat that came up. And remember, if people have any questions, if you could throw those in the Q&A specifically, just so that way we've got it in one thing. But
let's see.
So Andrew had said the location agnostic feature, I think, is critical. In an increasingly distributed, decentralized architecture, abstracting out location of resources is key. I agree with that, especially around when you think about cross-country things and stuff like that, that you might have even kind of different versions of the data that's available for each data product in each region. And so that somebody doesn't have to go, oh, I have to go, if you're in France and you want to get data from a data product and that team is centralized in Germany, you might, have to go to the data product in Germany, but there might also be a France one, and that company went and or that data product owner went and created that as well. So, and I think that the location sources is interesting. So you had something you wanted to add there as well?
Well, so what I was going to throw in there was the ability to run, location agnostic is critical, especially when it comes to our DR processes, because that is one of the most critical use cases, in that if you if you start to lose your application stack due to some sort of event, and your automation processes, your failover depends on that, you're not going to, I mean, turtles all the way down. You're not going to be in a good situation. And so, so that's one of the reasons that we built it this way, location agnostic, and so that, you know, the surviving components don't have to be manually redirected to certain targets. Sorry, I think I went off on a little bit of a tangent there, but
no. I think what you're talking about is kind of not DR, but DA, of disaster avoidance, you know, of if you've got something that is, it's almost like you think about a peer-to-peer kind of mesh, right? Of like that, it's not that any one thing ends up being as critical, and you might not be able to make that as applicable to other people and what they're thinking about with data mesh, but that you still are able to have those things where if a certain aspect of your infrastructure goes down for some reason, that you're still able to function in certain ways. And so you know, how that's kind of directly applicable is I'm struggling to figure that out. And Michael had asked specifically about the Hive.
Yeah. So that this was before I was mature, a little more mature in my development path, and I had no idea what Apache Hive was. So there's a bit of a conflict. This is not about Apache Hive. My apologies. But so that what the Hive does is the Hive will use the stereotypes. Let me bring that back up here. If we look at the person class, then I'm sorry. If we look at the class definition for the person class, we see that it has person ID, first name, last name, so on and so forth. The stereotype of person ID is applied as well as department name. So if we look, so what the Hive does is it will start up, it goes out to all the data sets, finds the keys, finds any of the stereotyped key data, and creates an index of those. So if we were to look up, let's say first names. Okay, so department name accounting. If we were to do a search on accounting, it'll find the object that is authoritative for that value, and then the child object, which in this case, you know, so the department object itself is authoritative, and then the person objects are going to be child objects to that. That was we did that so we could more quickly look up people and their related accounts, as well as, I know this sounds simple, but an IP address. If you think of something as simple as an IP address and everywhere it's referenced in the environment, how handy would it be to be able to say, here's an IP, here's an FQDN, give me all the objects we have related, and it crawls all of our systems looking for that. So we don't have to know which classes are stereotyped with it. We just pop in the value, it'll determine that and bring the objects back for us.
Yeah, interesting.
So,
yeah, I think, sorry to interrupt, but I think like this becomes really applicable even when you're thinking about like access to things of within the data catalog, right? When you're thinking about that data catalog of what do I have access to, and what, you know, how can I dig in a little bit deeper of like if it goes and it says this person already has access, you know, when you're thinking about federated governance in the mesh, if somebody is creating their product and saying these people have this access, you could use this kind of same thing with that key get of what do I already have access to, where I don't have to ask for permission to get access to X of this data product. And so somebody doesn't even have to put in, you know, when a lot of people talk about their governance, they talk about every single one is still, there's some approval base. It's just that it's not on a centralized team. But if you have that automated approval base, like I think that this is super applicable from that standpoint as well.
Yeah.
It's really interesting because, I mean, again, your use case ends up starting out so way outside of the norm, but it ends up enabling so many different things that other people could find super, super useful. So I think it's super interesting. And if you had anything to add there's a couple of questions in the Q&A that I also wanted to, we asked people to throw their questions in there. So,
okay, so I'd like to hit this one. See, Michael asked, also in the same declarative, I'm here, a source can also say I'm going away. How does that work? So I started up, I'm watching the topology queue on the local node, and I'm going into Docker to stop the test provider. It's currently shutting down. When that thing stops, let's see. I'm sorry, topology tracker. Watch the wrong name. Okay, so we're going to watch the topology tracker queue. We're going to start it back up. And what we'll see is events come through in the topology tracker, so that, and it's not just the node itself. Any process on the mesh should be able to observe events when their dependency services go offline. So if service C depends on A and B go offline, I should be able to monitor that and act on it by maybe flagging my own, this service as being disabled. So, so the question was, when it goes down, do you get the same thing? I've just stopped it, and we will see the removal of the, we'll see the node deletion, which will trigger the removal of the node services as well. Each node in the mesh has a copy of the topology table and the service table for things it has visibility to. Let's see, does it replace Kafka, Istio, MQ? Absolutely not. Not for the application stack. This is this was targeted towards the infrastructure sources. We have had one or two business groups ask about this because they during incidents where processes went down and they had to rely on our services to fail over, they kept asking. We've had a few ask, how is it that you're stayed up when everything else is going down in that data center? And so I'm going to be having that conversation, and it should be fun. As far as the naming goes, yeah, it's pronounced derp, South Park. So try and keep this quick. What had happened was I was explaining this to one of our architects about 2 years ago before I had a good idea of what it was supposed to be. And after about a 5-minute spiel of, this is what I'm going to do, this is how it's going to behave, what do you think? Very politely looked at me, said, sounds like a bunch of derp. And I was rather dejected, but I went home and thought, I can work with that. Declarative resource protocol, that'll work. So next, 11-year-olds tend to love that. I do too.
Yeah, and in the Q&A, somebody had also asked they pasted, Travis has pasted that in as well. So, and then, so Michael had said, I see this working on the topic of federated governance. Can the DRP kick services out that violate some X rules, right? Like this could be if somebody if it's not in the data catalog or, things like that. I don't know if specifically you've got that already enabled, or have you found, that useful, or can it do it? And have you found a use for that?
Not yet, but that's something that would have to be implemented if this were to ever touch the application stack. That's an excellent point.
Yeah, I think that it's really interesting because my brain is still trying to map how this would go towards other people that are building things that aren't specific to kind of the network infrastructure, because I think there's a lot of what you've done here. I mean, exactly what you've got here is you've got observability of, as nodes are coming up and down, that's the topology tracker, that you could have all of those different types of observability and thoughts around that, and whether people want that into, whether they want to use a tool that's kind of raw like this that pushes then into, some kind of thing to review logs, or whether they want a service that does this specifically. But
so one of the things we did end up doing with this was to map. We use the class data in those declarations and map them into a graph database. So it makes it much easier to create that graph database when you don't have to go through and enumerate every single source and have to integrate directly with every single source. When you can say, hey, give me the class data, and this is how I want to stitch it together, then generating your graph database, that content, it makes it easier.
Yeah, I like the concept of, there's been a lot of talk about manual entry into data catalog, and I don't love that, right? I love the kind of declaring at that concept, because you've got to have that broadcast out and of, okay, here is what I am, or hey, I just did a new update on this, or you could even think about this for schema changes and things like that of, people talk about like contracts and things like that, that if you had this as somebody who is, from a pub sub model, somebody who's subscribing to your contracts, that you could even subscribe almost to different specific aspects of that. And so, anybody who's subscribing to it, if they know that a schema change is coming, then they would have want to review that. But if there are different other aspects to that they, you don't just say, hey, we're going to be creating a new version, or hey, we're changing the way this is going to work, and everybody then has to review, is this going to break my downstream consumption of this? If there were more kind of granular downstream consumption type of understanding of that, especially when it's in like kind of a, somebody's in a Git branch thing where before they, when they're working on it, it's like, is this going to break downstream dependencies and things like that?
What I think that ties into Michael's comment about the federated governance, because you could take that and make it so that for a given, if I own a certain set of products and they're in a given zone, then I can take I can apply the rules so that products, if a product schema has changed, or if it's not honoring certain rules, then I don't relay that to anybody in my zone. So you could implement rules to have it reject things with unexpected schema changes. So a new service comes online and you depend on it. You would only interact with it if it honored what you think it should be provided. If it had what you think it should be providing, if it had the correct schema version, and so on and so forth.
Yeah, interesting. And we had 3 questions all pop in within about 3 seconds of each other in the Q&A. So I'll let you just kind of check those out and run through those.
Synchronization handled across regions. That is a good one. That is handled by the what we do with the logging is routed to multiple regions. But as you can imagine, when something gets disconnected, then it has to get synced over. Right now, it's a patchwork process, and there's no single mechanism for handling that. So it's still up to the individual processes. It's still up to the individual products to make sure that synchronization is handled. Let's see, automate. I'm sorry. Next question from Michael. You could also implement the authorization capability on top of that what service can and should talk to. Also auditing as it happens. Yes, we do actually do that. One of the elements on the node is one of the rules is the authentication rule. In the public site, it's an open authentication. Pretty much any name password is going to get you in. But in a production environment, obviously you're going to want to tie that into, we tie it into LDAP, but somebody else may want to tie it into, I don't know, OpenAM or whatever your chosen AAA method is. But the auditing, we take that very seriously because we give people a lot of capabilities they wouldn't normally have, especially at application owners on the mesh. And so it is crucial that every step they take that could result in a change that is logged centrally. That ties into the previous question of how is it synchronized? Right now it's again a patchwork process, but working on it.
And Andrew had asked about is this really like the catalog in the way that people think of that, right? Like because people, the way that data catalog is kind of trying to approach data mesh, at least from what we've seen of people doing. We had the panel with the people from Amundsen and from SelectStar and from DataHub and or Data.World, or all of the different catalog people are kind of in the community. So like, is this that kind of in-depth catalog level, or is this more of a here are the services, but it doesn't let that exploration level exist in there? Or like how are you thinking about what the catalog needs to have, or what you'd like to add on top of it, or what would be kind of more necessary for somebody doing kind of the more traditional data mesh approach?
So before I really understood what a catalog was, I might have said yes, because that's kind of what I was going for initially. But then I actually did some research on the topic. No, it's not a catalog. This is, you pointed it out earlier, this is simply an ephemeral snapshot at any given time. When you look at the topology, it's simply a point in time view of what's there, as well as the capability to view the changes. A data catalog could take advantage of that by having some sort of watchdog process that watches changes and evaluates those. That could be done, but no, this is definitely not a data catalog in and of itself. This actually does have a parallel to CMDBs in the IT management space, because CMDBs, you have to go in and have to add all your elements into the CMDB, so on and so forth. There's a ton of integration work that has to be done to get it all right. Data catalogs the same way, because they could both benefit from having the observation capabilities to changes in the topology. So it's kind of the same concept. Let's see, when I'm trying to open Jmesh, I'm sorry. When you open Jmesh IO, just put in any name and password, and it'll let you into the demo site. Sorry.
And I'll drop for people that are watching this after the fact. I'll drop that link as well. Jmesh.
Thank you, Travis.
I mean, it's not hard to remember jmesh.io, but still, I'll drop that into the YouTube.
That's the other problem with buying domain names before you do your research on it. Come to find out, yes, Jmesh is the name of a 3D rendering tool some guy in Germany made. So that's why I didn't actually choose that as the project name. I didn't want to have any kind of conflict there. It makes a good demo site.
I did that. Somebody already has, for data mesh OSS, I have DataMoss, which is just a terrible name, but it's memorable but like, somebody has the .com, but I've got the other stuff for that. But it's interesting. And Travis as well, I'll drop into the YouTube recording. He'd had done a blog post a while back, but I don't know if you recorded as well any of the, he'd done these things. We were trying to do topics forums where we basically just had people kind of jump together and just chat about things. And we were trying to do that pretty early on before we got the meetups running. So he might have, Pete, if you've got recordings of that, I'll drop those answers or drop those links in the YouTube as well. But
okay, I went ahead and posted the public project site to the chat.
Okay, and I'll drop that as well into the thing, into the YouTube when I post that. Anything else that you wanted? I know you've got kind of a room that you run a little bit in the Slack. So if you wanted to let people know about that room as well, where you're kind of talking about some of the different things around protocols and things like that. So if other people want to kind of get involved with this, what's the room or the channel in the Slack?
Sure. See, that is going to be the protocol brainstorming channel. And unfortunately, I haven't been active in there in a while, but after today, I'm definitely hopping back in to restart some conversations.
Yeah, and yeah, I think, I mean, this is the part of the issue with data mesh is that it's pretty much nobody's full-time job. Yeah. And so it's all like part of it. But yeah, I think with this type of stuff, there's some really interesting parallels that a lot of people could use for what they're applying to, and maybe, you know, put this in front of their people on their networking team. So, and then I think we've got one last question before we jump off, unless you've got anything you want to do.
No, that's just, I think somebody put Michael up to this question. No, this was a project I started a couple of years back just to make life easier, and it's just something I've been working on for, I don't know, I think the past 3-4 years thereabouts. So it's just me.
Yeah. So the question was specifically how big is the team that built this, and so the answer is one. It's Pete.
Just one.
So yes. So I think with that, we're kind of coming up at 10:30 Pacific and 1:30 Eastern, or I never remember my time zones very well. But I think that's a great time to wrap. But again, thanks so much for taking the time, Pete. And if anybody has questions, Pete is in the Slack. He's great person to chat with and work with. And, if anybody's seeing this is in the Bay Area, he's going to be out here soon. And we're looking at maybe doing a Bay Area lunch or something like that. So if anybody's interested in that, feel free to hit me up or Pete up, and we'll kind of work on that as well. So
absolutely. Hopefully Delta Airlines will treat my bike with respect, and I'll be able to ride while I'm out there. Looking forward to that.
If not, I've got a really crappy bike that you can use. You'll be very disappointed by if you want that. I don't even know. I don't know if it's mountain bike or I think it's combo or hybrid or whatever. I don't even know. So
we'll definitely have to touch base on that. Yeah.
Yeah. All right. Well, thanks everybody for joining, and thanks for the great questions and participation. So.
All right. Thank you very much, Scott.